Welcome to your next math tutor training set. These set of videos are about both rational expressions and radical expressions. So we'll talk about each of those, how to add and subtract with them, and we'll also talk about imaginary numbers in the third video. First, let's talk about rational expressions, and the root of the word rational is ratio, meaning fraction. So any number that can be written as a fraction of integers is a rational number, but when we talk about rational expressions, we're also going to throw in some variables in there too. But they're going to act very much like fractions with numbers. So let's talk about this one first. We have 54 over 72. We can obviously simplify that down. Instead of dividing though, I'm going to actually use some factoring to simplify it. We haven't talked too much about this before. And so 54, let's just break that down into 2 and 27. And then 27 breaks down even further. So we end up with 2 times 3, 3 times. 72, if we break that one down, we'd have 3 2's and 2 3's. Now whenever I see a number divided by itself, that can be 1, right? 2 divided by 2 is 1. 3 divided by 3 is 1. And 1. So I end up with over 2 times 2. Really, you'll hear a lot of people say that the 1's cancel, but really what happens is it becomes 1. So 1 times 1 times 1 times 3 is 3. 2 times 2 is 4. So I have completely simplified it because I have canceled or divided out the numbers that they have in common factors. So 3/4. We can do the same idea here with this rational expression that's got some variables. It's a binomial divided by a trinomial, right? And one thing you want to be careful of when you help students is they may be tempted to just cancel like we did before. But because of that minus sign, we're actually not multiplying and we cannot cancel out the x squared or even this minus 4, right? So be careful of that. What we want to do is factor. On top we have a difference of squares. I'm going to factor that. Square root of x squared is x. Square root of 4 is 2. Give myself a minus and a plus. Okay, on the bottom we have x squared minus 4x minus 12. That's going to factor into two different binomials. It's a fast trinomial, so we have a minus 6 and a plus 2. And that will give us negative 4 in the middle and negative 12 at the end. Now we see here is multiplication between the two parentheses, so because there's multiplication, I can cancel or divide out or factor out that x plus 2, it becomes 1. So it's really now x minus 2 over x minus 6. Again, I cannot cross out the x's or divide by 2 to get the 2 and the 6 to cancel. So that is completely done. Nothing else I can do. So for simplifying rational expressions, it's going to be very similar to with numbers, right? We factored everything that we could and then cancel or divide out the common factors. I didn't write process on this one, but just for simplifying, you just factor and then divide out anything that they have in common. Sometimes you'll factor and there won't be anything in common, and then you're done. It's as simplified as it can be. Alright, let's talk about adding and subtracting rational expressions, but of course they're just fractions, so let's start with the fractions first. Okay, we're going to do some factoring again as we look at this. So 13 is already factored because it's a prime number, and we have 6 times 7, but that would break down to 2 times 3 times 7. Again, this is a little bit different than how we've looked at common denominators before, but it's really helpful for using polynomials in a minute. 15 divided by 36. 15 we can say is 3 times 5. And 36 breaks down to 2 times 2 times 3 times 3, right? 4 times 9. Now already, even before we go on, we can simplify this fraction just by itself because there is a 3 divided by 3. So we're at 13 over 2 times 3 times 7 plus, that 3 is sideways. Fix it. There we go. And then we have 5 over 2 times 2 times 3. Okay, still not a common denominator, so I cannot add the numerators, but I can multiply in order to get the common denominator. So when I've factored everything, I'm going to have my common denominator have all the factors that it needs. Right, common denominator, so I need a 2 and a 2 and a 3 from the second fraction. And from the first fraction, I already have a 2 and a 3, I just need a 7. So what I'm going to do is I'm going to add in what each of the fractions needs. Well, multiply in, right? So the first fraction needs another 2, so I'm going to multiply it by 2. So then I get on top 26. And then my second fraction needs a 7. I'm going to add 35. And if you multiply the common denominator out on the bottom, you get 84. So 26 84ths plus 35 84ths. And now I can combine like terms, or combine numerators, excuse me, which are like terms. It works, I guess. And I get 61 over 84, which I then would check, multiply, factor, divide, check to see if I can simplify that anymore, and it's done. Can't simplify that anymore. So we're going to follow the same process. Oh, it's there, but I wrote over it this time. Alright, to add and subtract rational expressions, the same process as we just did with the fractions. Alright, close enough. First, factor to find the common denominator. Okay, then add or subtract. After we've gotten the common denominator, the numerators. Then simplify if we can. So we're going to look at this one first. 2 and 4 are already simplified, so just leave those the same. On the bottom of the first fraction, we have x plus 1 and x plus 2 if you factor that. And then the second fraction factors to be x plus 1 and x plus 3. Okay, even though there's x plus 1, we can't cancel anything because they're on completely different fractions in the denominator. So my common denominator is going to have all of the factors possible. X plus 1, I just start with the first fraction, x plus 2. My second fraction already has x plus 1, but I need x plus 3 to be represented. And so my first fraction, I'm going to multiply in what it needs. It needs an x plus 3. And I'm going to do that top and bottom. And my second fraction needs an x plus 2. And I multiply that on the top and the bottom. So I have 2 times x plus 3, okay, minus, now in the process it says be careful not to lose those, they can get lost with the fraction, x plus 2. I'm going to go ahead and give these all their own denominator, so I don't have to write it twice, it's so long to write. Alright, go ahead, and I'm going to go ahead and distribute that 2 and the minus 4, and we get 2x plus 6. And minus 4 x minus 8. Okay, I distributed, and now I'm still going to simplify the top. So 2x minus 4x combine like terms, I get negative 2x. 6 minus 8 is negative 2. Alright, and I have my denominator down here. So I have factored the bottom all out. I'm going to leave it that way because of the last step. It says simplify if you can, simplify if possible. So I'm going to actually take out a negative 2 and I can simplify it by taking out that x plus 1. Final answer, negative 2 over x plus 2 and x plus 3. So adding and subtracting rational expressions, same thing as adding and subtracting fractions. All the same steps. Oh, there's a scary one. Complex fractions. Not because they're really too scary, but because they have more steps than like the ones we just did. So there is a fraction within a fraction. Oh no, here's our process. We're going to simplify the top. We're going to simplify the bottom, and then we'll worry about the fact that it is a fraction over there, okay? So I'm going to go ahead and multiply this one by x plus 3, top and bottom. this one by x minus 3. And I get 5x plus 15. And here, negative 3x, plus 9. Remembering to distribute that minus, careful with the minuses. And I have x minus 3, x plus 3 as my common denominator once I've combined those. Alright, so simplifying on the top. Oh, I missed something important. There's an x there. That's x squared and 15x. There we go. So now, combining my terms and simplifying the top, I have 5x squared plus 12x plus 9. And then you can try and see if that factors. It does not, so we're just done with that so far. And my common denominator, x minus 3x plus 3. Okay. And I'm going to work on now the bottom of the fraction, which was 4 over x plus 3 and 12 over x squared minus 9. Factoring that, I get x plus 3 and x minus 3. So this one already has a nice common denominator. I'm going to go ahead and multiply x minus 3 for this fraction. Don't lose my plus sign. So I have 4 x minus 3 over my common denominator plus 12, because I didn't need to change that second fraction. Simplifying that, I got 4x minus 12. Ooh, that's nice. I love when things make 0. So that becomes 4x over x plus 3, x minus 3. And I'm just leaving that simplified in case I need to factor some things out. Alright, remember that this big fraction bar here means divide. So really what we have, if I write it horizontally, 12x plus 9 over x minus 3, x plus 3, divided by that second fraction, 4x over x plus 3, x minus 3. What do you do with fractions when you divide them? Keep the first one, change it to multiplication, and flip the second fraction. So that's what we're going to do. We're going to flip the second fraction. All over 4x. There we go. And look at this. I have things that can now become 1 or cancel. There we go. So I have final answer 5x squared plus 12x plus 9 all over 4x. There's nothing that will factor out completely from the top, and so I am done. If you wanted to, you could even put 4x under each of those terms and have 3 separate terms, but other than that, that's fine. That works too. Okay, for these ones, they look scary, so I hope your students know, yeah, it looks a little overwhelming. But just take it one piece at a time, right? Simplify the top, simplify the bottom, and then make sure you flip the second fraction so you can multiply them. That's the basics of rational expressions. Go ahead and watch the next video about radical ones.